Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from Group K, Section 20, Statistics Engineering. Today, we want to present to you about our project, which is we're given task to complete um, by our lecturer. At first, I want to introduce my fellow groupmate, which is my name is Muhammad Syahmi bin Mustafa, and we have Nordin Dahia binti Muhammad Zamri, Muhammad Syahmi Aiman bin Cik Mamat, and Norman Fu Teng Jun. Okay, we proceed to the first task. Okay, so we have been appointed to do um little bit calculation on statistics engineering. We have been given about 200 data sample, which is P-Lajak Kuruke. We have about 200 data sample for weight, relative density, tensile strength, and shift. For task A, we have to summarize all the sample data and show it in the different way, which is the table, the bar chart, and the pie chart. First of all, we class our sample data according to three shift, which is morning, evening, and night. And then we calculate the mean, the mode, and median for each shift, which using the Excel formula, which is mean the sum divided by the number of sample, mode, which is the highest one in the data sample, and the median, which is the middle one. For each parameter, which is weight, relative density, and tensile strength. So this is the result that we get. This is the bar chart from the table that we have built. And next, for the central tendency, um, same method, but we have to find the mean, the max, the range, standard deviation, and variance. The mean is the minimum value. Um, the max is maximum value. The range is the maximum minus minimum. Standard deviation and the variance for each shift. Okay, so this is the bar chart from the table up here. And then we have a pie chart which refer to the percentage production according to shift. From this pie chart, we can see that the most production is come from the night shift. Okay, so next we go to task B. We pass to the Norman Fu.
Hi, I'm Norman. So I'll be presenting for question B. So what is given is a sample size of 200 and the mean weight and standard deviation of 350 milligram and 40 milligram respectively. Assume X equals to weight of tablets and given the confidence interval of 95%, or in this case alpha equals to 0.05. So the hypothesis statements are H naught X tallies with the given values, given standard deviation, and mean. And then it is rejected if x squared test is more than x squared AV and H. And then the new hypothesis where x does not tally with the mean and standard deviation. So we use the following formula of Z for the data. The weight of tablets x is then split into intervals of 10 to get the ranges. And we got the OI which is counted through a data given in the Excel file, and the probability of P in terms of Z using the Z equation here again, and then the probability P of the value where it is taken directly from the statistics table, and the EI is then calculated. So for the EI value, for the value or I highlighted yellow is less, the frequency are less than 5. Then we add that into the next or the previous interval to get a EI value more than 5 to and create a new table is created with a new OI. And so the EI value is then recalculated. Sorry. So OI minus EI squared bracketed squared and over EI. So we got the new value x squared test. Now we must compare it with x squared AV, where V equals to k minus p minus 1. Since EI 5 for I equals to 1 and to 6, then k equals to 6. As the two parameters mean and standard deviation are known, then the number of parameters to be estimated equals to 0. So V equals to 6 minus 0 minus 1. So you got 5. So x squared AV following the statistics table equals to 11.0705. Since x squared test 6.63 is less than x squared AV, H naught is not rejected, meaning the data tallies with the standard deviation and the mean. That's all for me. Question B. Thank you.
Okay, thank you, Norman. Then we proceed to Ssce, which is presented by Syami Aiman.
Okay, now I will present for question C. Okay, for question C, we use one-way ANOVA. Okay, first of all, we must know the hypothesis for this question. Okay, by letting morning equal to 1, evening equal to 2, and night equal to 3, H naught we can get equal to mu1 equal to mu2 and equal to mu3. And for H1, we can know mu1 is not equal to uj. Okay, for to identify the value, we must summarize it by group. First of all, we have group 1, which is morning, group 2 for evening, and group 3 for the night. So we summarize it by know their count and sum, and after that from the count and sum we can get the average. Then after that we can find the variance. Okay, after we know all the summary for each group, okay, we will calculate the ANOVA by using the formula that have in statistical book. This formula. Okay. For first, sum of square. Okay. Between group, it is actually the SSTRT, and we can calculate it in book. Okay. For second between group, for sum of square, it is from SSE. And then for total it is from SST, and all this we can know by using the formula. Okay, for the degree of freedom, okay, we can know by find the k. The k in for this question is 3. So we will 3 minus 1 and then we will get 2. Okay. For the 197, it get from the total count, which is 200, and minus it with total, it is 197 and minus with 2. Okay. For mean square, we can get it by divide sum of square with degree of freedom. Okay, we can get it. For example, 185.9287 divided by 2. Okay, we can get 92.76437. Okay. After we get the mean square, we can find the f by divide two value of mean square, and we can using a Microsoft Excel we can get p value and f critical. Okay, okay, for decision rule, critical point is 3.041753. Okay, and we will reject HO if F test is more than F critical. Okay, for conclusion, since our F three, it is less than F critical, which is 3.04173, we will fail to reject HO. Okay. So at significant, alpha is 0.05 and p value is 0.562872 is less, is more, it's more than 0.05. We conclude that there is no exist of a significant difference in the means at 0.05 of level of significance. Okay, that's all from question C. Okay, next question for question D.
Okay, so next we go to question D. We pass to Nordin here.
And Dini, I will discuss about question D. From this question, it involves relative density and tensile stress. Relative density represents the independence, which is part CS, and tensile stress will represent dependence for part y-axis. From the first table, regression statistic, you can get the value of correlation coefficient R by the value is represented by multiple R, which is 0.8447. And from the third table, we can get confidence interval for relative density 95%, which is the value is 0.07395. From this data information, we can reject H null if p value or significant f is less than alpha 0.05. And as you can see, the value of significant f is less than alpha 0.05. Then we will reject H null. This conclude the data provides strong evidence that linear significance exists between x and y. For the model equation, y, you can identify the value from beta 1 and beta 2. For the model equation, the y head is negative 0.04907 plus 0.08112 x. The interpretation that can be made for the model simple linear equation. Okay, for the graph, the first graph is normal probability plot. As you can see, it can be plotted straight line. So normal as it's assumed normal satisfied. For the second graph, relative density graph, it plotted near zero axis, near to zero. So it was assumed normal satisfied. Relative density line fit plot. As you can see, the blue is represent as observed data, orange is predicted data. So positive linear hypothesis can be confirmed. That's all from me. Thank you.
Okay, so that's all from us, Group K. Thank you.